there, this video is going to talk about writing a biconditional statement as a conditional statement and its converse. So with these problems, we're given a situation. In this example, it says the table below gives the color and cost of light bulbs that were sold at a certain store, and these are the only light bulbs that the store sold. Now, we're given a biconditional statement down here. Let me read it with you and then explain what a biconditional statement is. It says a light bulb was yellow if and only if the light bulb cost $4. You're always going to see that phrase in a biconditional statement, if and only if. It's biconditional because it's a conditional statement simply because it's an if and then statement. It's saying if this is true, then this other thing is true. But it actually works both ways. You can pick either part of the statement to be the first part of the statement. And both of those should be true for the biconditional statement to be true. So it says to choose one of these. We're going to write the conditional statement. So what we can do is write this down as two if-then statements. So we'll start with just transforming this into an if-then statement in the same order. That will be our conditional statement. So if a light bulb was yellow, then the light bulb cost $4. So I took out that if and only if, and I just simply reworded a little bit with saying if this, then this. So if then the light bulb cost $4. Now to do the converse of that, we switch those around. So a converse is where we take an original conditional statement and we just swap the two phrases. So if the light bulb cost $4, then the light bulb was yellow. Okay, and those are our two statements. Now we need to see if that's even true for this given situation. So let's look up here. If a light bulb was yellow, then the light bulb cost $4. Well, let's go find the yellow light bulbs. If the light bulb was yellow, well, we'll look at the yellow light bulbs, then the light bulb costs $4. Yes, that is true. So let's mark that that's true. But let's look at the converse. Sometimes the converse can be kind of tricky with the table. Let's see. If a light bulb cost $4, then the light bulb was yellow. So we go and we look at the costs. So we have to go to what it's saying if. So if a light bulb costs $4, these two right here cost $4. Those are the two fours I'm seeing. So if I find something that costs $4, then the light bulb was yellow. Well, that's not always true. It could have been red. If I'm in the store and I find something that costs $4, it doesn't have to be a yellow light bulb. It could have been a red light bulb. So this one's not necessarily always true. Okay? And so because they're not both true, we can't say that the biconditional statement is totally true. Because if and only if is saying that it works both ways. That if the light bulb is yellow, then the light bulb costs $4. And also, if the light bulb costs $4, then the light bulb must be yellow. So that's not true both ways. So that means the biconditional statement is false. If we had gotten true for both of these, then the biconditional statement would have been true. Okay, I think the hardest part with these is part B. Trying to figure out if the conditional statement and a converse are true based on looking at the table. So be careful. You can only look at the part of the phrase that it's saying at the beginning. So if a light bulb is yellow, okay, go and look at the light bulbs and find just the yellow ones. But on the second one, if the light bulb costs $4, we say, okay, I'm going to go and find everything that costs $4, and there's two here. That's the problem. Because if there was only one, if the yellow one was the only one that cost $4, then that part would have been true. Alright, so good luck with these. I'm looking forward to seeing you all doing well.